Okay, so solving systems of equations, just like we did yesterday. When we talk about solving, we're talking about where these lines intersect. So our solution's actually going to be an xy coordinate. There's different ways to solve these. One way would be to graph the two lines, which we did already, but today we're specifically going to be using algebra, either using substitution or elimination. It's not going to tell you which one to use. You have to use whichever works best for that situation. Either one will work, but usually one of the two ways is less work in the long run. So for example, with number 1, we have this first equation, and then it says y equals 5x. For this one, substitution would be best because it just says y equals 5x. We can easily plug that in for y in this first equation, and then solve for x, and then solve for y. So depending on what we have here, and we'll see different situations where, for example, number 5, here we have the two equations. If we were to add these two equations, the y's would cancel right away, and then we'd be left with 2x equals 14, and we could easily solve for x. So depending on the situation, one way is usually better than the other, but both would work. So for number 1, so I know a lot of you are just working off a piece of paper. You don't have the notes printed, but we're going to just copy down the original problem. 4x plus 2y equals 7, and then y equals 5x. Then from here, like I said, substitution is the best for this because it just says y equals 5x. We can plug that in for y in the first equation. So 4x plus 2 times 5x equals 7. And now that we just have one variable, we can solve for that variable. And then x equals 1/2, or I like decimals, so I'll say 0.5. So for a coordinate, that would be our first coordinate, 0.5 or 1/2.
Wait.
Yes.
How did you get 5x?
Because y equals 5x. So I plugged in, since y equals 5x, I just plugged it in for y.
I thought
In the
2 times
first.
5x would be 10x.
Oh, I didn't see that.
So 14 divided by 7 is 2.
7 divided by 14.
7 divided by 14.
It's cool. Yes, root.
You can also just move the 5x to the other side, right? And put a 0 in front of it.
Yeah, and you could use elimination, but it might be more work to do that. But I know when I was in school, I preferred substitution, no matter how much work, I don't know. We're going to be using both ways. So here we have x equals 0.5. Now we can plug that back into either one of the equations. I would always choose the simpler of the two. So this second equation, y equals 5x, I can usually just do 5 times 0.5. Plug that in a calculator or do it in your head, y equals 2.5 or 5/2 or 2 1/2, however you want to look at that. Okay, there. Okay, number 2. Just writing the original. So I just copy this as is from the guided notes.
So it's. What is the coordinate answer for number 1?
It's x equal.
Oh, you wrote it off. Okay.
Yeah,
Sorry, it's spaced out.
that's cool. And you could write it as fractions or whatever you want. It's all the same thing. For number 2, I want to use elimination, but I need to rearrange it so like all lines up. So I'm going to put 3x minus 6y on this side and then so I'm going to put both of these in standard form essentially. So 3x minus 6y equals -6. And then for this one, I'm going to get 5y on the other side, so I'm going to subtract 5y from both sides. 4x minus 5y equals 4. still not able to cancel anything out.
You could multiply by -3.
Yeah, so if I multiply, so I can get the x's to cancel, I'm going to multiply this by 4 and then multiply this by -3. Okay, so I chose this, multiplying all this so my x's will cancel, so I'm just going to rewrite it after I multiply everything. So I would get 12x, thank you, minus 24y, -24. And now I can add these together. The x's will cancel. I get -9y equals -36. And y equals 4. By the way, for whatever reason, the first 2 or 3 problems are the most complicated. It actually gets easier down the page, so just so you know. So then once we get y equals 4, we can plug that back into one of the originals or any of these equations. It doesn't matter which one. So
Might need 2 sheets of paper.
like I said, the first couple are actually the longest for whatever reason. I don't know. So then solves it down to get x equals 6. And so the coordinate's x4, 6, 4. What's that?
Is that number 2?
That's number 2. Yes. Okay. Number 3. Ready?
Wait.
You can do it. I can't take too long because then we won't get it done. 3. So the original for number 3 is x plus 12y equals 68 and x equals 8y minus 12.
You said 3 is another really long one.
I don't remember. No, it's not. Okay, so we're going to, for 3 it has just x equals something, so I'm going to use substitution. I'm going to take this and plug it in for x in the original. And yes, you can work ahead. If you get this and you just want to speed through it, that is fine.
Use that as elimination.
You could. Yep. Okay, so I plugged that in for x, and now I can solve for y. So I get y equals 4. And then I can choose which one from the originals to plug this into. I'm going to plug it into the second one because it looks easier. And I get 20. Okay, I'm going to move over here to do number 4. So number 4, am I going too fast, too slow? Yes.
Doing fine. Yes, so
Yes. Okay, so number 4, the problem is x plus 3y equals 7, 2x minus 4y equals 24. So for this one, I want to use elimination, but I don't have anything that'll cancel yet, so I can multiply this by -2. and then the x's will cancel. So that's what I'm going to do. Multiply this by -2. I get -2x plus -6y.
Do you not have to multiply the bottom as well?
No, I'm going to keep it as is.
So,
So I chose -2 so I didn't have to do anything with the bottom. Like the x's will just cancel.
gotcha.
Okay, now that I got y equals -1, I can plug it in here.
I'm solving the bottom equation now, right?
What do you mean?
There's 2x minus 4y. Is that what we're solving, or no, we're solving the top one.
Yeah, I used the top one because it looked easier to work with.
Gotcha.
Either one would work though. Whoa, it's blurry. It's not allowed. There we go.
Go away.
A bug?
There's a huge ant, and I didn't notice it till it was crawling. It was crawling on my pencil. It went down my pencil and onto my desk.
That's
Hi, friend. Don't bug me, please.
You can put it outside if you want, or kill it, but it's up to you.
It's like a mutated fly.
Here, come here. It's not that big.
It might be a fly without wings.
Get on it, stupid. Where are you going?
Anyways, number 5. X plus y equals 12. And then x minus y equals 2.
Out of my hand. Go away. That's a lizard.
When I was coming into work the other day, have you ever seen like the big, huge palmetto bugs around here? They're like, I swear, like I'm not exaggerating. I swear it was like that big. Okay, I might be exaggerating by like an inch, but it was really big. I didn't want to kill it because I felt like I was killing like a small animal, and it was huge. Have you ever seen one that big?
What is this really like?
It was here on campus. It was like a big, like I guess they're called palmetto bugs, but it's like a cockroach like this big.
Their buzz is like.
Does it make a buzz?
Like cicadas.
Their buzz are.
Oh, the flying ones?
I was like 8 then.
No, it's like a deep
fear I had.
I don't know. Anyways, for number 5, we don't have to multiply anything. The y's are just going to cancel, which is nice. So we get 2x equals 14, x equals 7. So that's our first coordinate. And then once we get this, we can plug it into either one of those. X plus 7 oh wait, no, we don't do that. Put it in for x. So 7 plus y equals 12. And y equals 5.
Wait, x equals what?
7.
7. That's my kind of math problem. That one was. That one's okay.
Yeah, for whatever reason, they get kind of easier as we go. What's that?
If you put in for the x minus y, wouldn't that come out as -5?
I don't know. Okay, so 7. So if we put it in, 7 minus y equals 2.
Oh, but then you divide it.
Yeah, you're good. Okay. Numero 6. Do I have enough room here to do number 6? I guess we'll find out. 6, I get x plus 2y equals 10, and x plus y equals 6. That's the original for number 6. Good.
So it seems for a lot of them,
The x's will just
What's that?
cancel, right?
a lot of them, they already like
And
canceled.
you get them multiplied by negative.
Yeah, they do. Okay, so for number 6, I'm going to multiply this whole thing by -1. However, because I'm short on space here on this side of the page because I decided to do it here, I'm just going to put in my negatives here. So I'm multiplying this whole thing by -1 to make this negative, and this negative. And I'm just going to add right here. So x minus x would just be 0. 2y minus y will be y. And then 10 minus 6 is 4. Then once I have this, I can plug it into either one of these. So x plus 2 times 4 equals 10. X equals 2. So there's our coordinates.
I have an idea how to do it. Just do it so much faster than I do. Whatever.
Yeah. I used to get, when I was younger, I used to, like, not get in trouble, but get in trouble in math class because I would work so fast and then I'd make all these mistakes. I don't know. My brain works too fast for me. Okay, so number 7. The original is 3a plus 4b equals 9. And then just writing it as is. And what's nice is, yeah, it's just going to cancel without us having to multiply by anything. So 3a minus 3a is going to be just 0. 4b minus 2b will be 2b. And then 9 plus negative 3 will be 6. And b equals 3. So that is our second coordinate. And then once I get this, I can just plug it into one of these.
Which one are you plugging it into?
I did the first one. Some people were asking on the homework, like, if they don't use x and y, how do you know which goes where in the coordinates? Just go in the order of the problem. Here it looks like standard form, so this would be your x and your y.
I'm sure yours based on letter alphabetical order. Like
That too. Yeah, standard form does state that it should be in alphabetical order. Then number 8. Number 8 is 4x plus 2y equals 4, 6x plus 2y equals 8. In this case, I can multiply one of these by -1, and then the y's will cancel. That's what I'm going to do. I'm just going to multiply this whole thing by -1. I could rewrite it all, but honestly, just put a negative sign here. Save yourself some work. Okay. Then 4x minus 6x, -2x. These cancel, and then this equals -4.
Y equals -4?
X equals 2.
Oh.
And then once we get x equals 2, you plug it in. Yep, that's what I got too. Okay, next. You guys aren't yelling at me, so that's good. Okay, so over here, number 9. The original is x plus 3y equals 11, and then x plus 4y equals 14. The x's will cancel if I multiply one of these by -1. So multiplying all this by -1, I'm just going to put a negative symbol there.
Which one? You doing the second one?
Yeah. And then,
X plus
oh, what is this? X plus 4y. Yeah, the original was x plus 4y equals 14. So you had x plus 4y equals 14, and then I multiplied it all by -1, just put a negative symbol in front of everything.
what was the answer for number 8?
2, -2. Okay, then I get -y equals -3. And then once I get y equals 3, I can plug it in. I'm getting my flu shot today. Has anybody gotten theirs yet? My kids got theirs yesterday, and they said their arm was so sore. I don't know. I've had actually a lot of students leaving early with flu-like symptoms. I don't know if you've noticed. It must be going around.
That's what I said would happen. I'm not getting the flu though. Not it.
I'm just saying. I already had one today. And then yesterday I saw like 3 people leave in the middle of the day through the clinic. It's going around. Okay, so number 10. Okay, we got this. If I multiply this bottom one by -1, the y's will cancel. So again, I'm just going to use my little shortcut. Instead of having to rewrite everything, just make all these negative as if I'm multiplying by -1. Now this will cancel, and I get 2x equals 12. So x equals 6. And then I can plug this into one of the originals.
He's kicked my butt when I was taking Algebra 1.
Did your teacher get to this? I've noticed that a lot of teachers didn't teach this. I don't know.
We did something similar to it. I think it was at the end of the school year, but it was 100% online because it was right when
Oh.
COVID started, and I could not figure it out.
Let's see, there's 11.
I think my teacher skipped a lot though. She was not a very good teacher. You're doing a really good job of teaching algebra though, because I actually understand most
Thanks.
of what we taught so far. When I took algebra for the first time, I had no idea what was going on the entire school year.
Thanks, I appreciate that. Because, I don't know, I'm kind of a perfectionist and I like nitpick myself. I'm like, oh my gosh, I made a mistake. Or am I doing the right thing? Okay, thank you.
Learning.
Good.
That's my fault. Don't touch it.
Okay, number 11. I'm going to squeeze it in here. How are we doing on time? Oh, we're good on time. Number 11, just writing it out the way it is. 3x plus 2y equals 6. And then 3x plus 3 equals y.
So could we use substitution? Because y equals 3, or
Yeah.
should we just multiply it all by 1?
Either one. You could rearrange this and put y on the other side and 3 over here.
Yeah, so well, it does have 3x already, but you have to multiply it all by 1.
Yeah.
You don't have to, you just subtract and subtract.
Yeah, but technically it's the extra step, so.
Since we haven't done a substitution one in a while, I'll use substitution. So for this one, y equals this, so I can plug it in for the y here. 3x plus 2 times 3x plus 3 equals 6. So since y equals this, I just plugged it into the first one. So it'll be 9x equals 0. So x will equal 0. And I should have gone on the back because I'm running out of room. Okay, and then you can plug this into either one of these. I should zoom in too.
If you do the first one, it basically just becomes 2y equals 6. Zero three.
Yep. Okay, so if you need to, if you haven't already moved on to the back of your paper, I'm sure you're about to. I'm not going to move onto the back so I can still keep the one up on the screen. Okay, so 12.
I had to create little enclosed.
Okay, zooming it out so you can see the whole thing. So number 12.
Do your work.
Yeah, as long as it's-
Okay, so for number 12, if I multiply everything by -1 in one of the equations, the y's will cancel out. So here I go shortcutting things again. Okay, so I'm multiplying this whole thing by -1, so this becomes negative, this becomes positive, this becomes negative, and then I don't have to rewrite everything. So yeah, x equals 1. And then taking this, plugging it in.
Did you multiply the top by 1?
I did the bottom one by negative. Do you want me to show you it again?
Yeah.
Okay,
I
so,
have negative y equals.
right, so the original was this, 2x minus y equals 1. And then I said, okay, I'm just going to shortcut, multiply this whole thing by -1. So this becomes negative, this becomes positive, and then this becomes negative.
Oh.
Yeah.
What do you do to get rid of the negative y? Or does it just become a positive y?
So this one right here, I divided by -1, or you could multiply by -1.
Oh, because then you'd flip the sign if it was an inequality.
Yep.
Gotcha. So 1, 1.
Mm-hmm. Okay. I know your brains are probably getting tired because mine are too. This last row kind of brings in the like weird situations with fractions and stuff, and I don't like it. So just cross out 13 through 16.
Let's go.
I mean, oh, did you? If you worked ahead through it, you're awesome. Good job.
No, you're stupid for doing
Just,
it.
I know if my brain's getting tired, yours is probably getting tired too. Wait, we're not done, y'all. We're gonna do the word problem ones.
No, we're done.
Nope, we're not done. Okay. Number 17. Actually, these systems are just all over PSATs and SATs, as you saw. And one way they come up is in these word problems. But these word problems are really predictable. Somebody even said they saw this exact problem on the PSAT, which I'll have to ask Miss Adams where she got these. She like must know the secret.
Uh-oh.
Yeah, she's hacking the SAT somehow. I've had that happen though. Like if you know the curriculum well enough and you've seen the problems over and over again, you could almost like hack the test. That's the teachers that have been doing it for a long time. They know exactly what's going to be on the test.
Drew's just being like, no, I don't believe it.
What's that?
This was not on the PSAT.
He just said it's not. That's
Number 18?
Yeah, it wasn't.
Okay, look at number 18. People said they recognized it from the PSAT.
They
The-
might have used.
Well, there is different forms.
They must have been
There
on
is different forms.
because it was not.
The price of a sweater is $5 less than twice the price of a shirt. Anybody recognize that?
Yeah.
Similar.
It was
Haru, maybe you skipped it because you're too dumb to do it.
no.
You're like, man,
There's different forms, so
you
yeah,
go,
maybe
"Man,
it wasn't on
this
yours.
one's hard. I'm gonna skip it.
Whatever.
Anyways. Okay, so number 17, it says 2 records and 3 tapes cost $31. So I'm going to write that out. 2 records plus 3 tapes equals $31.
2R.
Yeah, R for records, T for tapes. 3 records and 2 tapes cost $29. So 3 records plus 2 tapes equals $29. Find the cost of each record and each tape. Okay.
29.
Yeah. Okay, so we could use elimination. I'm going to use elimination. It seems like it would be easier than rearranging these. So I'm going to multiply this by, let's say, 3, and I'll multiply this by -2, and then my r's will cancel. So rewriting this, 6r plus 9t. 3 times 31 would be 93. Then multiply this by -2.
Oh.
Okay, then the r's cancel. We're left with 5t equals 93 minus 58 is
Oh.
35. C equals 7. So 7 tapes. Then we can plug that into one of the OGs, the originals, to solve for R. 2R plus